half bridge inverter. Could you please tell me about the last topic of that inverter, last point? I can recall, but I want to know that thing from you. What was the last topic?
So the last topic was half bridge inverter, the voltage shapes, sir. Sir,
Is it like that?
so you like, sir, when we off on the switches as soon as to uh, what is the
Yeah,
shapes of
after
voltages?
the last topic, actually the ground isolation circuit and the ground isolation. If we improvise the ground isolation, then how the voltage will appear.
Oh, sorry, sir, sorry, sir. Yes, sir.
Hmm?
Yes, sir.
Is it okay? So far, I can remember that was the ground isolation and showing the ground isolation with the path transformer. And after that, is it okay with everyone, or I'm making a mistake?
No, sir. Sir, when we switch on off the switches, then what will be the voltage
Uh,
shapes? That was the last topic, sir. I guess.
did I tell you about the ground isolation or not?
No, sir.
Not. Actually, there was no topic regarding ground isolation. I am asking you.
Mm,
Please confirm.
no,
Otherwise,
sir. I think so.
okay. There is no topic regarding ground isolation. Okay. I'll start with ground isolation now. Maybe I made a mistake. This is the function generator, and there are two switches. According to the basic structure, we need to connect in this form. This is drain, this is source, this is again drain, this is again source. Okay, this is switch 1, so we are giving it gate 1, and this is switch 2, we are giving it gate 2. And to turn on the switches, we need to give a voltage in the point gate 1 and source, these 2 points. If we apply a voltage in here, and we need to apply a voltage in here, in between these 2 points. Here we need to apply a voltage, and we need to apply a voltage in here, like 10 to 12 volts. Okay, is it okay with you? So if
Sure,
we
sir.
want to apply a voltage, we need to think about the function generator and the synchronization of the signal. Okay, we need to produce the signal from the function generator. We need to produce the signal from the function generator. Okay, so if we produce a signal from the function generator, then what will happen? the same signal we have to apply with an inversion. And when we apply a signal from the function generator, sorry, I shouldn't apply signal from the function generator. This should be in this form, and whenever we apply a signal from function generator, there should be an inversion in here. Okay, so this point should be connected with this one. This is the ground point. Is it okay with you? Is it understandable?
Sir.
Is it understandable?
Yes, sir.
Mohammed Raqibul Islam. Mohammed Abu Darda.
Yes, sir.
Is it understandable?
Yes, sir.
Okay. Mirza Salem. Do you understand this part? We need to apply a voltage in between this point and in
Ji, sir.
between this point. So applying these two voltages, we can switch on. And here I have used an inverter in here. Okay. So when we make a connection in this form, what happens actually? You can see that this point is actually grounded. Okay, and this point actually this one is actually this one. So actually we are bypassing this MOSFET from the circuit. So whenever we just switch on the switch 1, then there is a short circuit path in here. Is it okay?
Yes, sir.
Do you have any confusion? You may ask. আমরা যখনই সুইচ 1 এর গ্রাউন্ডকে ফাংশন জেনারেটর গ্রাউন্ডের সাথে এক করে ফেলবো, তখনই আমার সুইচ 1টা আসলে শর্ট সার্কিট হয়ে যাবে। কখন? যখনই আমি গেটে একটা ইনপুট দেব, দেওয়া মাত্রই সুইচ 1টা শর্ট হয়ে গ্রাউন্ডের সাথে হয়ে যাবে, এবং V1 এবং V2 দুটো ভোল্টেজই শর্ট সার্কিট কারেন্ট ফ্লো করাবে সুইচ 1 দিয়ে। তার মানে অবশ্যই সুইচ 1টা পুড়ে যাবে।
স্যার পুড়ে যাবে কেন বুঝিনি স্যার।
শর্ট সার্কিট কারেন্ট ফ্লো করবে, there will be short circuit current through the drain to source and the green path. I have already drawn an orange path. খেয়াল করে দেখো, আমি একটা কমলা রঙের পথ এঁকেছি। এই পথ দিয়ে শর্ট সার্কিট কারেন্ট ফ্লো করবে, এবং এই কারেন্টটা ফ্লো করছে সুইচ 1 এর ভিতর দিয়ে। বোঝা গিয়েছে?
জি স্যার।
তাহলে আমার যদি সার্কিটের অন্য পথগুলোতে রেজিস্ট্যান্স বেশি না থাকে এবং ওই পরিমাণ কারেন্ট ফ্লো করানোর ক্ষমতা থাকে, তাহলে সুইচ 1টাই পড়বে। আর যদি অন্য পথ দিয়ে কারেন্ট ফ্লো করতে না পারে, তাহলে ওই পথগুলো পড়বে। যদি আমি পিসিবি লেয়ার ব্যবহার করি, তাহলে পিসিবি লেয়ারটাই পড়ে যেতে পারে। বোঝা গেছে? পিসিবিতে যদি আমি কপার লেয়ার চিন্তা করি, সেই কপার লেয়ারটাই পড়ে যাবে এই সার্কিটের জন্য। Is it clear? If you have any questions, you
Yes,
can
sir.
ask. Whenever you find the topic a difficult one, please let me know. Okay. So we may proceed in the next slide. We may proceed in the next slide, like here.
Sorry, you have shown this on yesterday. Really
Yes.
sorry.
Yes, I have the lecture video. Actually, I'm not worried about this point, since the video is downloaded a little bit in the morning, because it was a problem. But I used to make a note. You don't know, but maybe you also do not make a video or note of your class lecture. But whenever I have anything regarding my meetings or something, I always keep a note in front of me, so I know. But I'm not worried. Okay, it may happen, so I'm not worried about this point. Let it be. Okay, and I showed you in the red mark with here, there is an isolation in here, you know.
Yes, sir.
Yes, don't worry, I'll take only 5 to 10 minutes from this part. Function generator. Okay, it indicates that you do not actually make a copy of the class lecture. It's not good. The practice should be in this form. If you are smart enough, you may use a mobile device in a very good manner, like making a notes or something like this, any pad or something like this. You can use a digital pad. Or if you do not feel that I'm not so comfortable using those pads, then you should use a writing pad at least. That comes from the soft skill with a responsibility manner. Okay. Is it okay with you? Now I can say that there is a input voltage of V primary in here and the V secondary is in here, and there is no electrical connection here. There is no electrical connection. They are only magnetically connected. They are only magnetically connected. So there, since there is no electrical connection in here, whenever we switch on the switch S1, there will be no short circuit current in the system. So the load will see that it flows the current in this direction. Okay. Is it okay with you now? And whenever we give an input in here, the output will be inverted in here. So it will remain off. During that period, this switch remain off. Switch S2 will remain off and switch S1 will remain on. And whenever we will give a 0 in here, logically 0 in here, it will be logically 1 in here. So it will on. Okay, the main we are calling this as a pulse transformer. Okay.
Sir, I have a little confusion.
Please let me know.
Sir, when we We usually use square wave for switching, right, sir?
Mm-hmm.
Then will there be any effect of in transformer as we are using square wave?
Yes, I will just let you know now. Don't worry. So this is the usual practice around 80s. If you just open a circuit of power electronics board around 80s, you will find lots of pulse transformer inside the board. Okay, but the pulse transformer, if we draw the signal of a pulse transformer, this is the primary side and this is the secondary side. Okay, so this is Vp and this is Vs. Okay, so whenever we input, give some input in here, this is the input, but here this is an inductive load, so XL is here and XL is a function of F. XL is a function of F, and we can write this function as XL equals to 2 pi FL. Just a moment, I am coming. XL equal to 2 pi FL. Okay, now it's visible. And 2 pi FL, if you indicate 2 pi FL, that means if the frequency is high, then XL will also be high. So the current will be reduced. I will be reduced. If I is reduced, then flux will also be reduced. Okay, flux will also be reduced. And if the flux is reduced, we may not have the same flux in the secondary side. Flux coupling may hampered. So whenever we give a square pulse in the primary side, it becomes a little bit out of shape like this one. Okay, is it now clear with you? So there is a pulse distortion in the secondary side because these corners are actually formed with the help of high frequency input. With the help of high frequency input. Here. Is it okay?
Yes, sir.
So what should be the solution? We were using those things around 80s because during 80s we have developed the thyristor circuit, we have developed the triac, we have developed already the MOSFET with power side. So at the during 80s there are lots of innovation in the power electronics side, and at that time we have used those circuits a little bit. We have increased those parts because before those days, during 70s or 60s, we don't have any good quality motor drive in the system. We don't have any good quality power electronic circuits. You may also have seen that we have the mobile charger. There was no mobile charger like this one, semiconductor charger. Those are with transformers. Have you ever heard the term adapter? Adapter means actually a step-down transformer, which excuse me, which steps down the input voltage 9 volt, 6 volt, or even 5 volt. Okay, so we had those things in the early 90s or in the late 80s. but we don't have any power electronics devices. Okay, and those things were lossy. So using the this technique, it was not a good one. So we have developed a new concept of signaling, that is optical signal. Okay, do you tell me about the uses of optical signal? How many years ago we have developed those signals, optical signals? Do you have any idea? তোমাদের কি কারো কোনো আইডিয়া আছে যে অপটিক্যাল সিগন্যালের ব্যবহার কতদিনের পুরনো?
No, so 30-40 sir.
স্যার আরো আগে
Exactly. If you think about the use of optical signal in the human science, then it's very dates back to at least 2000 years back. During war, we have used those signals to show the matches or the lights to the soldiers to attack or not to attack. Okay, and if you go for more further days back, then you will find that whenever the people were doing some campfire or something like that, most of the people, other prehistoric era, they found that okay, there are some human race in there, so we can join with them. বুঝতে পেরেছো? অ্যানথ্রোপোলজি যদি পড়ো তাহলে দেখবা যে যে সকল মানুষ আগুন জ্বালাতে পারতো তাদের দিকেই অনেকেই ছুটে যেত, তাদের দাসত্ব স্বীকার করে নিত। এটা কি জানো?
জি স্যার, তাদেরকে ভয় পাইতো স্যার।
ভয়ও ছিল, আবার ভয়ে আসলে পশু পাখির ভয়টা বেশি ছিল, এবং যেহেতু তারা আগুন জ্বালাতে পারতো তাদের কাছ থেকে অন্য পশু পাখিরা দূরে থাকতো, হিংস্র বন্যপ্রাণীরা, সেই কারণে ওরা তাদের দাসত্বটা স্বীকার করে নিত, তাকেই লিডার ভাবতো। এটা প্রিহিস্টরিক এরা। সো দ্যাট ওয়াজ অলসো এ সিগন্যাল, এবং ওই সিগন্যালটা দেখে তারা আসলে আসতো যে এখানে আগুন জ্বলে রাতে, এখানে আলো পাওয়া যায়, আমি ওখানে যাব। You may consider it as a signal, but if you take the modern era, then optical signal is actually mostly used in the warfare. Okay, so let's back to the electronic side. Okay, whenever we have created a LED, an LED actually it's a light emitting diode, we can use this LED to make an optical signal. Okay, there is a light from the optical signal, and if we, sorry, if the light is inserted onto the base of the transistor, what will happen? The transistor will switch on. Okay, and if we just put off the light, then the transistor will be switched off. This is the basic concept of the optical signal in the power electronics. Okay, using this analogy, we can we can use a circuit using this circuit. This is an optical signal. Okay, so this is an integrated IC, and we can make it. Okay, do you have any confusion?
No sir, isn't it called sir optocoupler?
Yes, we call it as a optocoupler because it works in the coupling system. So optical coupling is working here. The coupling is done by optically, so we call it optocoupler or opto isolator also. Opto isolator also. Okay. And the voltage, the electric field strength is around 5000 volts in here. But don't get panic because it's not so high. You may think that 5000 volts is very low. Electric field is volts per centimeter or something like this. Electric field strength is volts per centimeter, but here the gap is very small, in the order of 0.0 millimeter or something like this. So if it is 0.0 millimeter, then it's not so large. Okay, the gap is very narrow in here. Okay. So do we have any question up to this point? So what will be the disadvantage of this circuit? The advantage of this circuit, that whenever we produce optical signal, it requires a very less energy compared to the magnetic signal. So the energy requirement will be less for the system. So the signaling system will not be loaded. Whenever we input a function generator in here, a very small current like 1 milliampere to 5 milliampere current will be drawn, not so big compared to the bus transformer. It's very small, maybe 20 times smaller, maybe 20 times smaller. At the same time, it's a capacitive device. This is a capacitive device. So since it is a capacitive device, here if we consider xc equals to 1 by twice pi fc, okay, then frequency term is a inversely proportional to xc. So whenever we see the output of this, if it is the input, of the circuit, the output will become square. Okay. And another interesting thing is that here we have used a transistor. So if we use a transistor in here, we can use it as a amplifier also. If this input voltage is 5 volt, we can make it amplified with a 12 volt. Okay. And another thing is that we can also change the output power in here. If we give a proper choice of voltage source with this circuit, with this part, we can amplify the signal also. So the function generator may produce a very small amount of power, signal power, but we can increase the signal power for the thyristor or even MOSFET or even IGBT. That's the main advantage of this opto isolator or optical coupler. Do you have any question?
Sir,
Ask me manually also if you find it difficult, because from now on we'll try to give you lectures or deliver our lectures in English. So I think it will improve your listening ability, and my English proficiency will also be improved day by day, no doubt. You know, language is a communication tool. It's a, don't if you take it sportsly, then it will help you a lot. And if you do not take it sportsly and you think that it's actually imposing, you may lose something, and you may lose these things by yourself only. It's a practicing tool. তোমরা হয়তো শুনে অবাক হবা, have you ever joined with any auction market? বাংলাদেশে তোমরা কি কখনো নিলামের ডাক শুনেছো কোথাও?
yes sir.
কোথায়?
মুভিতে দেখছি স্যার।
এই যে বাজারে স্যার, মাছের বাজারে।
এক্স্যাক্টলি, গুড। মাছ বাজারে যদি তুমি ভোরবেলা যাও 5টা থেকে 6টার মধ্যে, তাহলে তুমি কিন্তু নিলামের ডাক শুনবা। How fast it is? এই আমি কিন্তু গল্প করছি অন্য কারণে, তোমরা এর মধ্যে জিনিসটা আত্মস্থ করবে, যার মধ্যে কোনো কোশ্চেন অ্যারাইজ করবে তাকে আমি একটা ব্রিফ টাইম দিচ্ছি। ব্রিফ টাইমের মধ্যে আমি সোশ্যাল কিছু কথাবার্তা বলবো যেগুলো আসলে তোমাদের অভিজ্ঞতা বাড়াতে সাহায্য করতে পারে। ইট মে হেল্প ইউ। ওকে, আচ্ছা, এটা বলার কারণ হচ্ছে নিলামের ডাকে তোমরা যদি দেখো, হ্যাঁ, দেখবা যে কত দ্রুততার সাথে ডাক হয়, এটা কি খেয়াল করেছো? হ্যাঁ,
জি স্যার।
জি স্যার।
আচ্ছা, আমি এই নিলামের ডাক শোনার জন্য, হ্যাঁ, জাপানে গাড়ির অকশন মার্কেটে গিয়েছিলাম। টয়োটা একটা অকশন মার্কেট হয়, ওদের প্রতিটা গাড়ি 6 থেকে 10 সেকেন্ডের মধ্যে নিলামে ওঠে। এই 10 সেকেন্ডের মধ্যে তোমাকে চুজ করতে হবে তুমি গাড়িটা কিনবা কি কিনবা না। বুঝতে পেরেছো?
স্যার এটা তো গাড়িটা তো স্যার অনলাইনেও হয়।
অনলাইনে হয়, এবং অনলাইনেও তোমাকে ওই খুব দ্রুততার সাথেই করতে
জি
হবে,
স্যার।
ঠিক না? আর সেখানে আমি ওইটা অনলাইনে সবগুলা তো আসে না, অফলাইনে মানে যদি তুমি অনিয়াতে যাও তাহলে ওই গাড়িটা তো দেখাও যায়, একদম সব তুমি দেখতে পারবে। তো সেটা পরে ইস্যু, সেই অপশন জাপানিজে হয়, এবং সেখানে তোমার খুব, তো এই জিনিসটা বোঝার জন্য আমি জাপানিজটা ওইভাবে শিখছিলাম, জাস্ট টু দ্য ল্যাঙ্গুয়েজ ওয়ে টু মেক ইট এ স্পোর্টসি। যে এটা আসলে কিভাবে করে, এটা একটা অভিজ্ঞতা, মানুষ এই ধরনের অভিজ্ঞতাও নেই, ঠিক আছে? আমাদের সাথে একজন ভদ্রলোক ছিলেন, উনি বাংলাদেশে এখনো আছেন। তো ওনাকে জাপানিজরা টোকিও স্টক এক্সচেঞ্জ, হি ওয়াজ ইন ইকোনমিক্স, হিজ মেজর ওয়াজ ইকোনমিক্স। তো ওনাকে তারা টোকিও স্টক এক্সচেঞ্জের ফ্রি টিকিট দিয়েছিল, ইউ ক্যান এন্টার, পাস, ফ্রি পাস, যে আপনি দেখতে পাবেন যে টোকিও স্টক এক্সচেঞ্জ কিভাবে মুভ করে, কিভাবে কত বিডিং শুরু হয়, কিভাবে আসে। আপনি টানা 3 দিন থেকে আপনি দেখে আসতে পারবেন, 3 দিনের একটা পাস, মানডে থেকে ইয়ে পর্যন্ত, মানে স্টার্টিং থেকে মিড পর্যন্ত আপনি দেখেন, লাস্ট ডে হয়তো না দেখলে হবে, 3 দিনের একটা পাস। উনি বললেন কি দূর, ওটা দেখে আমি কি করব? বুঝতে পারছো? উনি কিন্তু বাংলাদেশি ব্যাংক ম্যানেজমেন্টের উপর কাজ করেন, কিন্তু উনি বলতেছেন যেটা দেখে আমি কি করব? এটা দেখতে গেলে আমার শুধু যদি ওখানে খরচ হবে, কিন্তু হি ওয়াজ, মানে তাকে ওটাকে দেওয়া হয়েছিল তার বুলেট ট্রেনের টিকিট এবং হোটেলে একটা মিন্স দিয়ে, যে আপনি এই ধরনের হোটেলে থাকতে পারবেন, 3 স্টার হোটেলে থেকে আপনি দেখে আসতে পারবেন। দূরে এত কষ্ট করে ওখানে যায় কি? তা খেয়াল করে দেখুন, দুজনের দুই ধরনের মানসিকতা, স্পোর্টস নিবে কি নিবে না। তো ইংলিশে যদি আমরা ক্লাস করি, তোমরা আমাদেরকে বাংলা কোশ্চেন করতে পারো, হ্যাঁ, একদম চুপ হয়ে থেকো না, কিন্তু দেখি স্পোর্টস, দেখবা যে 2 দিন পরে তুমি সুন্দর ইংলিশে কোশ্চেন করা শিখেছো। এবং আই ডু অ্যাপ্রিসিয়েট অ্যাবাউট মিস্টার মশিউর রহমান, who was asking me in English. I really appreciable. Okay, so it's a communication tool. It will make you more vocal. It will give you another, how can I say, feather to your hat. It will be an addition point, because if you just join in a seminar or in a webinar in an English language, then you'll find yourself more comfortable. Okay, so do we have any question regarding this opto-isolator now? If it is okay with you, then I can proceed.
স্যার,
The next, yes, please.
এই যে মাঝখানে ওই জিনিসটা যদি আবার একটু মানে ব্রিফলি বোঝাতেন স্যার, যে কিভাবে, লাইক স্যার, যখন স্যার যে অপটিক্যাল স্যার ইটা কিভাবে আসে স্যার, মানে বিজেটি যখন স্যার ওই যে অফ অন হবে স্যার, ওই জিনিসটা কিভাবে হবে স্যার?
Okay, it's good point. So I will draw the whole circuit first. Then if I just complete the circuit, then it will be much more easier with you. It's good question, no doubt. Let's start with a function generator. This is our function generator. Okay, the green box actually the opto isolator or optical coupler. Okay, this is the main circuit function generator produces. We'll put a resistance in here. We'll put another resistance in here, and this is a complete different voltage source. This one is a completely different voltage source. So it will be in here. So how the circuit will work? Whenever we'll give a voltage in here, this is the square output. This one is on. We can say it logically 1, and this is off. We can call it logically 0. Is it okay up to this point? Is it okay?
Yes, sir.
To everyone? Mr. Khalidul Islam. Khalidul Islam, are you in or out? Can you hear me?
Yes, sir.
Okay. Is it okay with you?
Yes, sir.
So the current will flow from this point. So the light will emit. Okay. And we have to connect the output in here. So there will be current flow in this direction also. So if we consider a voltage output, okay, I'll make it red one. If we consider a voltage output from these 2 points, then we can see that if it is V in, so the voltage output will be, whenever the switch is on, the voltage output will be 0. And when the switch is off, the voltage output will be V in. Like a transistor connected in this form. Sorry. If we connect a transistor in this form, whenever we put a base current in here, the output will be 0. Is it okay? The terminal voltage will be 0. And whenever the IB equals to 0, then terminal voltage will be V. If we just place a VCC in here, this will be VCC. Is it okay with you? You are habituated with this type of connection, the black one.
Yes, sir.
Okay.
Yes, sir.
Do you understand? So I have done the same thing in the secondary side of the opto isolator. Okay. Do you have any question?
So when we turning on the lights, then how the transistor is
Will work to get the current, base current or something like this. Actually, the
yes,
base
sir.
is actually light activated. So whenever the base is light activated, you are inserting light, so the base is getting current. And we make the base light activated base using a PN junction. The IR sensor. Do you recall the system of IR sensor?
Yes, sir. Infrared Okay, sir.
Yes, the same topology. Actually, we are using whenever we just insert a light in the PN junction, the light produces H into new energy. So some parts of carriers will jump to the higher level, and whenever they will fall, they will flow a current. They will create a flow of charge. In the how can I say, in the conduction band and valence band, there is a jump whenever we just put some energy in here, they will jump to this state. Okay, and if it is a PN junction like here, then these electrons will just fall from here. Do you know those things? In the electronic circuit, you have actually studied those things.
Yes, sir. Now it's clear, sir. Okay.
Now it's clear. So the base actually light activated base. So whenever we just insert some lights in the base, so it will create a flow of charge. So if the flow of charge is in the microampere order, then we may get milliampere order in the collector to emitter side. Okay, it may happen. Is it okay with you now? So what we are going to do next? We have to use this type of optical isolator in the circuit. Please draw the picture so that you will also learn. Okay, so you'll find an interesting thing in here. We have the function generator, and the function generator using the optoisolator circuit connection, you'll find that inversion in here. So whenever we produce logically 1 in here, this will give a logical 1 input in here, but in here you'll get the logically 0, because whenever the base the light will be inserted onto the base of the transistor, so the transistor will remain on. So if the transistor is remain on, the circuit connection shows that it will be short with the source. Okay. Here this is a short point, so you will find 0. Whenever you have inserted logically 0 in here, this will remain 0. There will be no light output from here, so this transistor will remain off. So this is logically 1 now. Is it okay with you, everyone?
Yes, sir.
Is it clear? So considering the voltage source, you may use this amplifier circuit also. Here we can use it as an amplifier. If this voltage is like logically 1 from the function generator is 5 volt, we have to use this voltage as 5 volt. So all the MOSFETs will get 5 volt, both. Okay. So do you have any question up to this point? Okay. Do you have any question? So these are the advantages and disadvantages of an optical isolator. The circuit is a little bit complex and another IC is required. So the ground isolation, for that ground isolation, half bridge inverter is a little bit complex, and for that reason it is a little bit expensive than push-pull inverter, and 2 voltage sources are required with same amplitude. Okay. Tomorrow you have a makeup class with me.
जी सर.
A regular makeup class of Wednesday. So please take care. I'm just now giving you the attendance. Nusrat Sultana Kea, Muhammad Ariful Islam, Muhammad Abu Darda,
Yes, sir.
Muhammad Mushfiq Rahman, Salsabil Faria,
Present, sir.
Barzana Umama,
Sir, present.
Sadia Sharmin, Minhaj Ahmed, Salman Huda, Faria Rohim, Lamia Sharmin, Sumaya Hassan,
Yes, sir.
Sadman Haq,
Yes, sir.
Mirza Salem,
Yes, sir.
Mirza Salem,
Yes sir. Yes sir. Mirza Salam sir. Yes sir.
Anand Sarbidia, Murshida Khatun,
Yes, sir.
Afia Mustafa,
Yes, sir.
Khalil Hassan,
Yes, sir.
Abu Kalam,
Yes, sir.
Ajul Hakim,
Present, sir.
Mohammad Samiul Islam,
Present, sir.
SK Abdul Rahim Sabbir,
Present, sir.
Sifatul Alam, Fahmida Ashrafi,
Yes, sir.
Mohammad Asaduzzaman,
Yes, sir.
Sukhdev Das,
Present, sir.
Nuruddin Sakib,
Yes, sir.
তারপর হচ্ছে মশিউর রহমান,
Present, sir.
খালেদুল ইসলাম, আব্দুল্লাহ আল মুশাররফ,
Yes, sir.
সৈয়দ নাফিসা তাসনিম,
Yes, sir.
আসিফ বিন নিজাম, মোহাম্মদ শাহিদ আমিন,
Yes, sir.
Sir, Sifatul Alam, sir.
ইফাতুল আলম,
Sir, 171048, sir.
হ্যাঁ পেয়েছি,
Okay, sir.
ফারিয়া হায়দার চৌধুরী,
Present, sir.
মহসিনা তাহসিন,
Yes, sir.
আয়শা আবেদিন,
Yes, sir.
মোহাম্মদ তহিদুজ্জামান,
Yes, sir.
অজল কুমার ঘোষ,
Yes, sir.
রাকিবুল ইসলাম খান,
Yes, sir.
কেউ কি বাদ পড়েছো?
স্যার আসিফ বিন নিজাম।
আইডিটা একটু বলো না। 021
স্যার 1711090।
স্যার 1711080 স্যার খালেদুল ইসলাম।
খালিদুল ইসলাম,
জি স্যার।
আসিফ বিন নিজাম।
জি স্যার।
ওকে, আর কেউ বাদ পড়েছো? সেভ করে দিলাম। হ্যাঁ,
স্যার আমি স্যার সাদমান হক স্যার দিছিলেন কি?
টপিকে যাই। জি দিয়েছি। Okay, let's start. Next is actually full bridge inverter. So in a full bridge inverter, the circuit is like this. Do you find any similarity or resemble with any circuit? Do you find any similarity to any circuit? Dear students, I'll call you again, so don't worry. So if I'll call you again in 10:15, 10:25. So if someone is left the meeting, then he will be absent again. We don't have any other options because sometimes you make a lot of.
এতবার হবে অ্যাটেন্ডেন্স?
জি, দুইবার হবে, আরেকবার হবে। এবং আমি একটা করব স্যাম্পলিং র্যান্ডম, আর একটা করব শেষে। কারণ স্টুডেন্টরা আগে ডেকে ফেললে চলে যায়, আর যদি শেষে ডাকি তাহলে এসে লাস্টে জয়েন করে। 10:20, 10:30, 10:15, 10:10 এই সময় জয়েন করে। এটা কমন প্র্যাকটিস হয়ে গেছে, সবাই কমপ্লেন করে এটা নিয়ে এখন। It's not good actually. Okay, so it's a very similar circuit with have you ever heard understand this circuit before?
স্যার কিছুটা চপার সার্কিটের মতো।
4 quadrant operation of a chopper circuit. কিছুটা না, it's the same. In the chopper circuit, the S1 and S2 remain open or closed for a long time to complete the motion. But here, since we are using as an inverter, the load is actually an AC load. We make it in a higher frequency compared to the chopper circuit. The frequency may be in here like 10 Hz, 50 Hz, 100 Hz, but in the chopper circuit, the frequency may be 0.01 Hz each 10 seconds or something like this, or maybe more or less. Exact. Okay. In the chopper circuit, we'll close switch 1 and switch 2 for a long time, like 10 seconds, 20 seconds, and even minutes. But in here, it will be in the order of millisecond. Okay. So the overall circuit is very simple. Whenever we switch on the S1 and S2, there will be current flow in this direction. Here, and if we switch on and switch off in this direction, there is a current flow in this direction. Okay, is it understandable? So you'll get the AC output. You will get the AC output. Do you have any question regarding this point? So what are the advantages of this one? If we just take the points here, we have used only one voltage source. If we take the, and if we want to make the output voltage 220 volt like this, so if we want to make the output voltage 220 volt and this is 220 volt, so the Vin will be 220. Okay. Does anyone have any question regarding this point? Do you have any question regarding this point? If you don't have a question, now we can proceed. So there is only one voltage source, V1, and using this voltage source, we can get the output of a 220 volt like this. And whenever we switch on the S1 switch, this one is on, this point is actually short, so switch S will face only 220 volt. Is it clear? Fahmida Ashrafi, is it clear?
স্যার আমি ঠিকভাবে বুঝতে পারিনি অ্যাকচুয়ালি এটা।
Okay, you have to
স্যার
say
আমি
it.
সরি বাট আমি এটা বুঝতে পারিনি।
প্লিজ বলবা। আমি কি বাংলায় বলবো?
না স্যার মানে আমি জাস্ট স্কিপ করে গিয়েছি, মানে আমি ওটা বুঝতে পারছিলাম না, আমি ওটা দেখছিলামই আপনি কল করছেন।
How can I help you?
আমি এখানটাতে মানে ঠিক বুঝলাম না স্যার, মানে এই যে মানে এই সুইচটা অফ, মানে এই জিনিসটা আমি মানে ঠিক ক্লিয়ার হয়নি স্যার একদমই।
In the half bridge class or in just only in this class?
স্যার হাফ ব্রিজটার হচ্ছে আমি ভিডিওটা হচ্ছে এখন পর্যন্ত ভালোভাবে দেখতে পারিনি, তো আমার ওটা আরেকবার দেখতে হতো, ওই জন্য মেবি এটাতে আমি একটু স্কিপ করে গিয়েছি।
Okay, so how can I help you? Should I explain it
জি স্যার,
again?
জি স্যার, জি স্যার, এটা একটু যদি আরেকবার বলতেন স্যার।
So whenever we work with a full bridge inverter, switch S1 and S2 will close in the same time. Whenever the switch S1 is closed, this switch is closed, the voltage in this point actually it's 220 volt. Between these 2 points, voltage between these 2 points is actually 220 volt. So we are considering this is a short path. So voltage between these 2 points, the red one, I'm giving the number, it's 0.3 and this is 0.0 and this is 0.1. Voltage between 0.3 and 0 will be 220. Is it clear?
Yes sir. Yes sir.
If the voltage is between 0.0 and 3 is 220, then this point is also a short with this ground point. So voltage between 0 and 3 is actually 220. So hence the source, switch S4 will face 220 volt at its across. Okay.
Yes sir.
Now is it now clear with you?
Yes sir. Yes sir.
Okay. And when switch S2 is also a short, with S1, then actually the ground point is in here, in 0. Okay, and the ground point is in here 0, so the same thing, here is 220, so switch S3 will face 220 volts. Is it okay with you now?
Yes, sir.
And
yes, sir.
Here the green 0 and the red 3 is the load. Green 0 is a 0 and red 3 is 220. So the load will also face 220 volt. Is it okay with you?
Yes, sir. I understood, sir.
Is it okay with everyone?
Yes, sir. Yes, sir.
Clear? Ajul Hakim,
Yes, sir.
Asif bin Nizam.
Sir,
Yes,
could you
sir.
please repeat for
Is it okay?
S3? Sir?
Sure. Whenever we close the switch S2, the ground 0 will appear at the point the green 0.
Right.
This is the connecting point of S3 and S2. Okay.
Okay.
Is it okay? And
Sir,
this
up to this
the
point is
220
okay, but
green.
yes, sir, please go on.
And 220 is in here. So the top point of S3 will also face, will see 220. So the voltage between S3, terminal of S3 is actually 220 volts.
220. Okay, sir, I understand now.
Okay.
Okay, sir.
Is it okay with you now?
Yes, sir, it's okay.
Okay. And if you see then again, the connecting point of S3 and S2, the green 0 is actually 0, and the opposite side of red 3 is 220. So the load will face a 220 volts. Is it okay?
Yes, sir.
Okay. Do you have any question? So what are the interesting points of full bridge? Full bridge circuit is simple as like we have already studied in the DC motor drive, but here the frequency will be higher. And the interesting point is it has only a single source, single power source. So there is no chance of defined voltage in the system, and each switch suffer actually the breakdown voltage is actually the actual voltage of the load. It's not like in the half bridge we have found that it is 440. In the half bridge circuit it is 440 volts, but in the full bridge it is the same as the load voltage 220. So we can make a good choice of our switch in here. Okay. So do you have any question?
No, sir.
So what will be the disadvantage of this circuit?
So we have to use more switches for tracer.
Which one is expensive, switch or transformer? Which one is lossy, switch or transformer?
So transformer.
Which one is costly, voltage source or switch? Which one is costly? Make the two voltage source equal amplitude or using a single amplitude?
Single source.
Make a good judgment. Okay. I'm just giving you the points. You may think because you are just you are going to become a fresh graduate, and I am actually an old guy. So my judgment is different from yours. So don't get worried. Okay. Oh, sure. I'm just doing
yes,
some take it sportsly.
Sure, sir.
we are using only two switches, and the main problem is you have to think we have to use at least two ground isolation circuit for S1 and S3. Here is S1, here is S2, here is S3, here is S4. We need at least two ground isolation circuit.
স্যার দেখা যাচ্ছে না।
Why?
স্যার জুম হয়ে আছে।
না স্যার দেখা যাচ্ছে স্যার, মানে দেখা
Yes,
যাচ্ছে স্যার।
I have written that thing.
এখন দেখা যাচ্ছে।
No, it was working because my student is also showing me that it's working.
স্যার একটু আগে দেখা
Okay.
যাচ্ছিল না, জুম হয়েছিল জাস্ট উপরের ওই যে কোণার অংশটুকু।
Oh, that's your problem. That's your problem. Maybe your network is not refreshing, or your PC is not supporting the Google Meet. It may happen. Only the done or something like this is in the system, like this corner.
Yes, sir.
It happens. It happens to me sometimes, but it's not problem with the others.
Okay, sir.
Okay, so whenever we just use we need two ground isolation circuits and the synchronization circuit also. So we have to use an optocoupler in here and another optocoupler in here, and you have to complete the circuit. It is your homework. Okay, but you have only one function generator. Function generator is only one, because if you use multiple function generator, you may not synchronize them properly. Okay, and we do not actually use multiple function generator. We use only one function generator to drive this circuit. Okay, so that's the point of complexity of this circuit. Okay, do you have any question up to this point? So it is your homework, and you have to submit it by this weekend, by Thursday. Okay.
Then, sir, why should we use that?
প্রেসার হয়ে যাবে স্যার।
Hmm?
স্যার টাইমটা একটু মানে শুক্রবার পর্যন্ত করে দেওয়া যায় না স্যার?
It may take only 10 minutes to complete.
জি স্যার।
If you are attentive in the class. I have already done for half for you.
স্যার কোশ্চেনটা আরেকবার বলবেন।
That's the point.
আরেকবার বলে দিলে ভালো হয়।
You have to draw the another coupling circuit. I have already done this for you. It was already completed. Yes?
স্যার মানে স্যার বুঝতে পারিনি স্যার, মানে আমি এখানে কি স্যার পুরাটা
একটা পার্ট আসলে আমি পার্টটা করে দিয়েছি না তোমাদেরকে?
জি স্যার।
তুমি এখন ওই পাশে আরেকটা পার্ট রাখবা।
ও আচ্ছা, একটু কি স্যার? ওকে স্যার।
এবং হ্যাঁ, এই একই ফাংশন জেনারেটর ব্যবহার করে আনবা, দেখবা যে লজিক্যালি ঠিক আছে কিনা।
ওকে স্যার।
So it's not so big deal.
স্যার আগের পেজে যে কোশ্চেনটা আরেকবার ভালো করে।
Sure. It's your circuit. There are four switches in here. Switch S1 and switch S3 require optocoupler. Okay, so you have to place those optocoupler properly using MOSFET and function generator, but you have to use only one function generator. Okay, you have to use only one function generator. There is a system is a little bit hang. Not working. Okay, now it's good. There are switch S1 and S3. You need two ground isolation circuit for these two switches. Okay. Okay,
Yes,
we
sir.
need to use two ground isolation circuit, two optocoupled circuit for these two switches. Is your homework. Okay.
Okay.
So, do you have any question regarding this
স্যার
point?
আমাদের তাহলে দুইটা ফিগার রাখতে হবে, একটা অপ্টো কাপলার দিয়ে আর একটা গ্রাউন্ড আইসোলেশন সার্কিট।
No, the same, the one circuit with a big page. The whole page you will require to complete the circuit.
Sir, we will send the docs via what? LMS or mail?
LMS. I'll give you the LMS access.
Okay, sir.
Okay. Just make a good practice. Otherwise, I don't know. It's actually not being graded as a points, good points. I'll give you small points in here, just to make you practice to make a good practice of this isolation circuit. Okay. After now, this do you have any question? So, if we start from the very beginning of this inverter circuit, we have studied single phase inverters with three topologies. One is push pull, the other is half bridge, and the last one is full bridge. In the push pull circuit, we have to use a center tap transformer. Okay, no way, we have to use a center tapped transformer. And in the center tap transformer, this is a there is a loss in the transformer. Okay, and the transformer is bulky, but the design is very simple. Hence, the push pull is a very inexpensive inverter. Next, we have studied the half bridge inverter. In the half bridge inverter, we don't need a transformer, but we need two voltage sources. Two voltage sources, power voltage sources, to operate or drive the system. So in the and we need a ground isolation circuit also. So the circuit is a little bit complex. So it's not so inexpensive compared to the push-pull circuit. And in the full bridge circuit, we have only one voltage source compared to the half bridge circuit. And there is no transformer, so the loss is very less. And since there is no transformer in the in the half bridge and in the full bridge circuit, we can make it in a very small way compared to the push-pull one. And there is no transformer, so there is no loss in the transformer side. Only the switching loss is here. Only the switching loss is here. And the switching losses are in the all circuits, we have some switching losses. Okay. So if we figure out the switching loss for all circuits, what will happen? VDS, IDS, power at the switch. Okay. When the switch is off, here is the time. Up to this point, the switch is off, then the switch is on, and the switch is off. When the switch is off, we have a VDS, and we have switch on here. So VDS will be 0. Okay. Just a moment. I'll draw VDS in a green color, so it will be understandable. So when the VDS is on, off, there is a VDS is here. Okay, is it understandable? When the switch is on, VDS will be almost 0, but not 0. Is it okay? And when the switch is off, VDS will be equal to V in or V load. Okay. Do you understand?
Yes, sir.
Yes, sir.
So what will the current? Current will be almost 0 when the VDS is when the switch is off. Almost 0. Okay. But there is a leakage current in here. The current will be almost 0. And when the switch is on, the current will be like this. The load current, I load. And when the switch is again off, there will be only a small leakage current. Is it okay with you? So what will be the switch power? If we multiply IDS and VDS, multiplication of ID and VDS will give the idea of switch power. So the switch power will be like on the off state, there will be like, oh, sorry. And there will be a spike of current and power, and this one, and again there will be a spike of current, and this one will be reduced to off like this. Since the leakage current is very small, off state loss is relatively small, but the on state loss is actually we calculate from the MOSFET. If we calculate MOSFET, then the load current I square means the load into RDS on, and the value of RDS is around like 0.2 ohm, 0.1 ohm, like this. Okay. Is it okay with you? So let's consider a load with 500 volts and 50 ampere. If the load is 5 and the leakage current is around in the order of like 0.1 ampere. Okay, this is the leakage current. Okay, if this is the leakage current, then the off-state loss actually around 50 watt. We are calculating this one multiplied by this one. Okay, on-state loss 50 square gun multiplied by 0.2. So 50 square means 0.2. So
So 500.
50 square into multiplied by 0.2 means 500 watt. Okay. Okay, do you have any question? Can you hear me?
Yes, sir.
So each
Yes,
cycle
sir.
has a loss of around 550 watt of each switch. So you may think that, wow, it's a huge loss. But if you just consider the total load actually 25,000 watt. So if you divide 550 with 25,000, what will be the percentage of loss, switch loss? Could you please do it for me? 550 divided by 25,000. What is the value?
It's a 0.22.
Sir, 2.2%.
2.2%. Good. So most of the time we found the inverter efficiency around 95 to 96%. So this is not a big loss actually. Okay. So it may happen. Okay. I have taken leakage current a lot. Leakage current is around 50 to 70 milliampere, and RDS on actually 0.1 ohm or something like this. You'll find in the data sheet. So, do you have any question now? So I can conclude this class.
Sir, if the voltage range is too much higher, so power, like if we design inverter for 10 kVA, and then which topology normally is used?
10 kV is not a big one. 10 kV means 8
Yes,
kilowatt
sir.
roughly. 8 kilowatt is not a big inverter. It may happen like 100 kilowatts or more. You know, in the UIU main building, each inverter is around 20 kilowatt. 20 kilowatt is not a big
Rooftop
one.
for solar, sir.
Yes, in the machine room. Yeah. And the escalator inverters are more higher rating, 25 kilowatt or something like this.
Then sir, for those things
গুলি তো
which
স্যার সবসময় এত কারেন্ট টানে না, বা ওগুলি তো স্যার বন্ধ মানে কমে থাকে না স্যার। ধরেন লোক যখন চলে, লোড যখন পায় তখন বাড়ে।
Exactly. This is the peak load.
জি স্যার।
We need to consider every time about the peak load.
ও আচ্ছা আচ্ছা, জি স্যার।
Okay. So.
Then sir, for those big things, how should we design, like, sir, or which topology is used normally?
Full base.
Full base.
No doubt, full base. If you use a 20 kVA transformer, it's a huge one, and it's a lossy one. Transformer may be 10% loss in the transformer, so it's a huge loss. Wastage of money in the air. You are
Yes, sir.
just
That's why I'm asking.
generating lots of heat using your own money. You are generating heat, so we shouldn't do it. So not the half base. The main topology we use actually the full base.
Okay, sir.
So if there is no problem, then we can conclude this class. We may, shall we? I'm just closing the recording.
Sure, sir.